Welcome back to the Topic Plus Revision Series. This is the Day 12 walkthrough and today's topic is Indices and Surds. As always, have your booklet ready and we'll go through the answers together in this video. So in these first few questions, we're asked to simplify some indices. Now to simplify just means to write it as a single power. So in this case, we're going to try and write it as 4 to the power of something. What we're going to do is we're just going to look at these two powers here and we're going to add those together. So 3 plus 5 gives us 8. So the answer to that first one is 4 to the 8 because we've multiplied those two. In the second question, we're dividing. So again, our base doesn't change. We remain with 6. And instead of adding these two index numbers, we're going to subtract them. So 10 take away 4 is 6. And we end up with 6 to the power of 6. Final question on this slide. If we have got 5 to the power of 3 and then in brackets to the power of 2, all we're going to do with these two is we're going to multiply them by one another. So 3 times 2 is 6, so we end up with 5 to the power of 6. And each of those is simplified. So when we're told to simplify, we write it as a single power, so 4 to the power of 8, 6 to the power of 6, or 5 to the power of 6. So these next few questions look similar to the three that we've just done. However, we're asked to evaluate instead of simplify in this case. Now to evaluate means to work out the value. So let's see what that means. We'll start by simplifying this first one. So again, we know that when we multiply these two, we're going to add the powers. So 8 plus negative 4, or 8 take away 4, gives us 2 to the power of 4. Now that's simplified. To evaluate, we need to work out what 2 to the power of 4 is. So 2 to the power of 4 is 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Now you don't need to write this middle bit, but you can if you're forgetting what 2 to the power of 4 means. Next one, we're going to use a similar thing. We're going to simplify first. So we get 5 take away 2, so that's 3 to the power of 3. And then 3 cubed, or 3 times 3 times 3, is just 27. Final question here then. 10 to the power of 3, then to the power of 4, is 10 to the power of 3 times 4, which is 12. Now 10 to the power of 12 might seem like a big number, but all we need to do is write 1 with 12 zeros. That's all that means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you should be able to do 10 to the power of any number. So in each of these cases, the difference between simplify and evaluate is simplify means you have to get it down to 2 to the power of 4, 3 to the power of 3, 10 to the power of 12 in these questions. But to evaluate means you need to work out the value. So work out what 2 to the power of 4 is, what 3 to the power of 3 is, or what 10 to the power of 12 is. Now back to simplifying, but again we've got some algebra involved here. So in this case, we're going to do the coefficients or the numbers before the letters separate, and then we're going to do the letters themselves or the variables. So in this first question, we've got 2 times 3 to give us 6, and then with our x's, we do the normal rule we have when we multiply. We just add the powers, so that gives us 6x to the power of 7. The second one, again doing the same thing with our coefficients. 12 divided by 6 is 2, and then we're going to subtract our powers here, and we get y to the power of minus 1. So we can have 2y to the minus 1. Finally, with this one, sometimes we get confusions with these type of questions C. What we have to do is we have to do 3 to the power of 3. So we have to apply that power to this. So 3 cubed is 27. And then we're going to multiply these two. And then that's m to the power of 15. Now the reason we have to do that is because what this actually means is 3m to the 5 times 3m to the 5 times 3m to the 5. And then we can clearly see 3 times 3 times 3 gives us our 27, and then m to the power of 5 times m to the power of 5 times m to the power of 5 gives us our m to the power of 15. Now the next questions ask us to write each of the following as a single power of 7. Now this idea of a power of 7, what that means is we should finish with 7 to the power of something. Okay, so a power of 7 means 7 to the power of something. Power of 5 means 5 to the power of something. Power of 9 means 9 to the power of something. So when you see a power of something, that base number is what that 7 tells us. So this power of 7, that tells us what the base is going to be. So in this case, the base is going to be 7. So what we do in this one, when we've got a fraction, all that means is we're dividing them. So that's the same as saying 7 to the 9 divided by 7 to the 15. And then we know all we're doing here is subtracting those two indices. So we get 9 take away 15 is negative 6. So as a single power of 7, that's 7 to the power of minus 6. Now with the next one, we've got some order of operations going on here. We've got some brackets that we need to deal with first. So this first set of brackets, we know we're adding these two. So we get 7 to the power of minus 1 divided by, and then the next one, 7 to the power of minus 10. Now remember, when we divide, we subtract those. So we're doing 7 to the power of minus 1 subtract negative 10. Now when we subtract negative 10, that's the same as saying add 10, and we end up with 7 to the power of 9. Okay, so again, our order of operations, or our bit mass, is in play here. But we also have to make sure that at the end we remember this, when we're dividing, we subtract, and subtracting a negative is the same as adding, and then our minus 1 plus 10 is 9. So remember, a single power of 7 means 7 is our base, and then we have to work out whatever our index is going to be. So these two questions are moving on to fractional and negative indices. Now these questions are exclusive to the higher paper and tend to be where students start to trip up. So all we have to remember is that this bottom value is our root, and the top value is our power or our index. So what this means is we're just going to find the cubed root of 64. Now there's no point in saying to the power of 1, because anything to the power of 1 is itself, so we can just ignore that. If it's a 1 on the top, we can just ignore that. So cubed root of 64 is 4, because 4 to the power of 3 is 64, so the cubed root of 64 is 4. The next one, we've got a lot going on here. The bottom value is our root, the top value is our index, and this minus means we're going to find the reciprocal. Now if you don't know what the reciprocal is, in terms of a fraction, it just means you flip the fraction. So in this case, we're not talking about the power though, we're talking about flipping the base. So let's deal with the minus first. We're going to start our first step, we're going to flip over this base. So we're going to get 125 over 27. Remember, we do not flip the index, so it stays as 2 over 3. Next thing we're going to do is we're going to find the cubed root of the top and bottom. So the cubed root of 125 is 5, and the cubed root of 27 is 3. And then we still have that 2 on top to deal with. And then simply doing that, squaring 5 is 25, and squaring 3 is 9. Now you can apply the squared first and try and do 125 squared and 27 squared, and then try and cube root that answer. But with these questions on a non-calculator paper, they tend to be, if you do the root first and then the index, it tends to work out a little bit easier for you. So that's our answer simplified. Now our final question on indices asks us to write the following as a single power of 2. Now we can see here that there's a 2 to the 7, there's an 8 squared, there's a 4, and there's a 16. Now in these cases we need to change the bases. Now what we need to remember is that, well, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and 2 to the power 5 is 32. And these tend to be the only ones that come up in your exam. They could keep going, but as you'll notice, all we're doing is doubling each value as we go along. So we're going to replace each number in this with a power of 2. So if we rewrite this fraction, we've got 2 to the power 7 multiplied by, our 8 is going to change to 2 cubed, and that's still squared, divided by 4, which is 2 to the power 2, all over 16, which is 2 to the power of 4. Now, as we evaluate this, 2 to the 7 times 2 to the 6 divided by 2 to the 2, all over 2 to the 4. If we tidy up the top, again, when we multiply our first two, we're going to add this 7 and 6 to get 13. And then because it's divide, we're going to subtract that 2. So 13 take away 2 is 11. So that's 2 to the 11 over 2 to the 4. And then as we've seen before, that fraction just means we divide. So we're going to subtract the two of those and get 2 to the power of 7. Now it asked us to write as a single power of 2, so that's fine. We don't need to evaluate it. That's our final answer. Now we're moving on to surds, and surds are very similar to indices in the sense that they've got similar rules that are happening. If you're not sure what a surd is the square root of a non-square number. So, for example, we know that the square root of 64 is 8. We know that the square root of 49 is 7. We know the square root of 9 is 3. However, the square root of 50, we don't know what that is. Okay, it's not just going to give us an integer value. We know that 49 is 7, so it's a little bit more than 7, but it is a surd. So what we want to do is try and simplify this surd. Now to simplify a surd, what we want to do is look at the factors of that number. So the factors of 50 are 1 times 50, 2 times 25, 4 doesn't work, and then we've got 5 times 10, and that's all of our factors. Now what we want to do is identify the largest square number in here. So in this case it's 25, so this is the pair we're going to use. Remember, if you don't know your square numbers, you can list them at the start. So 1 squared is 1, 2 squared is 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared is 36, etc. And you can keep going like that. You should know the first 15 square numbers to allow you to do any question in GCSE Maths on a non-calculator paper. And surds tends to be exclusively a non-calculator topic because with the calculator you just put it in there and it will simplify it for you. So this root 50 becomes root 25 times 2. I like to put my square number first. Then all we do is find the square root of 25, which is 5. So that's now on the outside of my surd. And then I've got the square root, and then I don't know what the square root of 2 is. It's not a square number. So our answer then of root 50 simplified is 5 root 2. Now in this next question we're asked to add two surds. Now with surds, when it comes to adding or subtracting, so to add or subtract, it's a bit like algebra. We collect what we'll refer to as like surds. What that means is we must have the same square root in both. So if we're adding or subtracting they're not like surds, we're going to simplify first. So if we simplify 28, well 28 can be written as 4 times 7, and the square root of 4 is 2, so that can be written as 2 root 7. Okay, 63 can be written as 9 times 7, and then the square root of 9 is 3, so that's 3 root 7. Again, if you need to, you can list all your factors like we did before and find the one that contains a square number. Now if you look carefully, we've got like surds. We've got a root 7 and we've got root 7. So we've got 2 root 7s plus 3 root 7, which then just gives us 5 root 7. So because they're like surds, we just add the numbers on the outside and we end up with 5 root 7. Now when it comes to multiplying and dividing with surds, we don't have to apply the same principle as we did when we were adding and subtracting. They don't have to be like surds. Okay, what we do when we multiply and divide is we calculate with the coefficients, i.e. the numbers before the surds, and then second we calculate with the surds. Now similarly, when we did adding and subtracting, we said we're going to simplify first. When we multiply and divide, we're going to simplify last. So it's the last thing we're going to do, and you'll see that in one of these questions. So very simply in this first one, we've got 4 and 3 on the outside. So 4 times 3 gives us 12, and then root 6 times root 2 is the square root of 12. Now the square root of 12 can be simplified. If we do it over here, square root of 12 can be written as root 4 times 3, and the square root of 4 is 2, so that's 2 root 3. So we've got 12, there's actually a little invisible multiply sign here. So 12 times root 12 is the same thing as saying 12 times 2 root 3, which is 24 root 3. And that's our simplified answer. For division, we do the same thing. We just look at our outsides. 12 divided by 2 gives us 6. And then 10 divided by 2 gives us root 5. And luckily for us, root 5 doesn't simplify, so that's our final answer, which makes it nice and quick. Now in this question, we've got surds in some brackets, but we've got double brackets position. So it's like when we expanded our double brackets that we saw in our previous video. We're just working with surds this time. So we're going to multiply our root 2 by both of the values in our other bracket, and we're going to multiply our 3 by both of the values in our other bracket. So starting with the root 2. Root 2 times 5 is 5 root 2. Root 2 times minus root 2 is minus root 4. 3 times 5 is 15. And then 3 times minus root 2 is minus 3 root 2. Now, this root 4 here can be simplified because we know the square root of 4. The square root of 4 is 2. So this is just negative 2 plus 15 minus 3 root 2. And like we said before, when we simplify in algebra, we collect like terms. Here we can collect like surds. So we've got 5 root 2, take away 3 root 2. That gives us 2 root 2. And then we've got minus 2 plus 15, or that's the same as saying 15 take away 2, which is 13. So our answer is 2 root 2 plus 13, or if you wish, 13 plus 2 root 2. Either of those two answers is absolutely acceptable. Now this question asks us to rationalize and simplify 10 over root 2. Now if you don't know what rationalize means, it's worth spending some time looking it up and figuring out what it means. In a very simple sense, in surds, rationalizing the denominator means no surds in denominator. Okay, so a surd is what we call an irrational number. To rationalize means just to get rid of that surd on the bottom. Now what we're going to do here is we're going to, like we do with normal fractions, we're going to multiply the top and bottom by the same thing. In this case, we're going to multiply it by root 2 over root 2. Now that root 2 came from here. And the reason that is if I have root 3 and I times it by root 3, well that gives me root 9, which is just 3. Now the shortcut is obviously that because it's a root times itself, it just gives you the number under the root. So again, if I had root 7 times root 7, that would just give me 7. So the reason I've chosen root 2 in this question is because that root 2 times root 2 on the bottom will just give me 2. And then 10 times root 2 on the top just gives me 10 root 2. Remember, to rationalize means we want no surds in the denominator. So our denominator now has no surds. Now we can simplify this because we've got a 10 on the outside and a 2 on the outside. So 10 divided by 2 gives me 5 root 2 as my final answer. Now, final question here asks us to rationalize and simplify again. But what you'll notice is our denominator is a bit different this time. There's a 2 minus root 6, not just a root 2 like we saw in the last question. In this case, what we're going to multiply by is the same thing as the bottom, but instead of having a minus, we're going to have a plus. So whatever this sign is, you're going to do the opposite. And then remember the top and bottom need to be the same. So this is what we get. Now, if we expand the top, 4 times 2 gives us 8. And then 4 times root 6 is plus 4 root 6. Now on the bottom, we might want to do this on the side. We get 2 minus root 6 and 2 plus root 6. Expanding those like we did a few moments ago, 2 times 2 is 4. 2 times root 6 is plus 2 root 6. Minus root 6 times 2 is minus 2 root 6. And then minus root 6 times plus root 6 is just minus 6. Now, because it's plus 2 root 6 and minus 2 root 6, those two things cancel each other out. And then we're just doing 4 subtract 6, which is negative 2. So my denominator is negative 2. Simplifying this then by dividing through by my negative 2. Again, I don't divide my surd, just the numbers on the outside. I get negative 4 minus 2 root 6. And that's my final answer. Now, one thing to note here, to make this part a little bit quicker, we know that every time it's going to be the same thing, just with a different sign in the middle. So all we actually had to do here was do 2 squared minus root 6 squared. If we do that, that gives us 4 minus 6, which gave us our minus 2. So if we just square the first one and then square the second one and subtract them from each other, that gives us the denominator that we needed. As always, thank you so much for watching. I hope you found this video useful and that it helped you to answer any of those questions you were finding a bit difficult. The full playlist of all the videos from the series so far can be found by clicking the link below, and we'll see you in the next video.